Hello everyone, in this lecture you will learn bubble sort algorithm. Below I will write an array of size 5. First of all, we will rotate this array 90 degrees. And for bubble sort algorithm, we do not need to write index numbers. At first, we will compare 12 with 9, and because of 12 is larger than 9, they swap their positions. And after the swap operation, the next shape will be like this. And in this form, 12 is larger than 11, and they swap their positions again. After this swap operation, the next shape will be like this. And in this form, 12 is larger than 7. And again, they swap their positions. At last, because of 12 is larger than 6, they swap their positions again. After the swap operation, the next shape will be. Now we sorted 12 because 12 is located at the end of the list. Also, we can call the 12 as the heaviest element in the list. And the procedure that we did is called first pass. And in total, we made 4 comparison: first, second, third, and fourth. In total, 4 comparison. Or we can say with 5 elements in the array, we made 4 comparison. If we had n elements, then we would make n-1 comparison. And we made 4 swaps in total. Because 12 is sorted, it is located in red circle. Now let's make second pass. And we will be doing our comparison on the new list shown above. We will use this list for the second pass. Our new list is 9, 11, 7, 6, and 12. At first, we will compare 9 with 11. Because 11 is located under 9, we do not make any swaps on this comparison. Next, we compare 11 with 7. And because 11 is larger than 7, we swap their positions. And after the swap operation, the new shape will be. And now we compare 11 with 6. And again 11 is larger than 6, we swap their positions. After swap operation, our new list. At the fourth form, this form, we do not compare 11 with 12. Because 12 is already in sorted order. In the second pass, we made 3 comparison. First comparison, second comparison, and third comparison. In total, 3 comparison. But we made 2 swaps. We made swap on this list and on this list, in total 2 lists. But we assume that we can make at most 3 swaps. So we write our swap number as 3. Because 12 and 11 is sorted now, they are located in red circle. We sorted 11 and 12. Now let's make third pass. And we will be doing our comparison on the new list. And our new list is 9, 7, 6, 11, and 12. And this is our third pass. At first we compare 9 with 7, and because 9 is larger than 7, we swap their positions. And in the second form we compare 9 and 6 again, and 9 is larger than 6, so we swap their positions. At the third form, this is our third form, 9, 11, and 12 will be sorted. And I am taking them inside red circle again to show that they are in sorted order. And in the third pass, we made 1, 2 comparison and 1, 2 swaps in total. Now let's make fourth pass. And at the fourth pass, we will be using 7, 6, 9, 11, and 12. At first, we will compare 7 and 6, and as you can guess, we will swap their positions. At the second form, 6, 7, 9, 11, and 12 will be all sorted, and I am taking them inside red circle in order to tell that all our elements are sorted. We made 1 comparison and 1 swap operation. Now, as a result, we can make some analysis based on our number of comparisons and swaps. We have 5 elements in our array. And we made in total 4 passes. First pass, second pass, third pass, and fourth pass. So if we had n elements, we would make n minus 1 passes. Also, as a result, at our last pass, we made 1 comparison and 2 comparison on the third pass, 2 comparison on the third pass, and 3 comparison on the second pass, and 4 comparison on the first pass. So we can add these comparisons like this. 1 comparison at the last pass, 2 comparison, third pass, and the 3 comparison at the second pass, and 4 comparison at the first pass. So if we had n elements in our array, the number of comparison would be look like this: 1 plus, 2 plus, 3 plus, n minus 1. n minus 1 because for 5 elements we reached 4, which is 5 minus 1. And the above equation can be written as n minus 1 multiplied by n divided by 2, which equals to n square minus n divided by 2. And we can simplify as order n square. And our time complexity will be quadratic time, which is not efficient. Our time complexity is order n square, quadratic time, based on number of comparisons. Also, the number of swaps can be written as 1 plus, 2 plus, 3 plus, 4. And if we apply the same procedure to the equation shown below, we would calculate the same result as order n square. So why do they call this algorithm as bubble sort? In the first pass, the biggest element or the biggest number goes to the bottom. 12 was here, and at the end of the first pass, it goes to the end of the list. And in the second passes, smaller elements or the lighter elements goes up, like the bubbles if you throw a stone to a river. Also, in order to analyze an assorting algorithm, we have to think about its adaptive property. If we process an sorted array, the time taken to sort this array should be less time consuming. For example, below let's write an sorted array: 6, 7, 9, 11, and 12. If we run bubble sort on this array, in our first pass we have to compare 6 with 7. Because 6 is smaller than 7, we do not make any swaps, so we continue. And on the second list, we compare 7 with 9. Because 7 is smaller than 9, we do not make any swaps, so we continue and we compare 9 with 11. And also 9 is smaller than 11, we do not make any swaps and we continue and we compare 11 with 12. And at last, also 11 is smaller than 12, we do not make any swaps. In total, we made 4 comparisons: first, second, third, and 4. 4 comparisons in total for sorted array, and 0 swaps for sorted array. If we had n elements, we would make n minus 1 comparison. And by this analysis, we can say that our time complexity becomes order n. So for bubble sort, the minimum time is order n and the maximum time is order n square. And for sorted arrays, we will consume less time than mixed arrays. So we can say that bubble sort is adaptive. But in order to make bubble sort algorithm as adaptive, we need to use a flag variable. Also, in order to analyze an sorting algorithm, we have to think about its stable property. I can explain the stable property by giving this example. Below, I give an example of 5 students with their exam results and their names. The above results are sorted based on their names: America, Brazil, Britain, Canada, Denmark, and Egypt. And as you can see, Britain and Denmark has the same exam result, which is 78. When we sort this list, Britain and Denmark should keep their positions unchanged because they have the same result. If they keep their positions same, they are called stable. Now let's sort the list based on their marks. First, Egypt comes to the first, then and Brazil. After Brazil, there are two 78 in the list. So which 78 will come first? If Britain comes next, this algorithm can be called as stable because Denmark didn't come before Britain. So Britain will come here with 78, Denmark 78, and Canada 79. So Britain and Denmark didn't change their positions. In the first list, Britain was listed before Denmark, and in the second list, Britain keeps its position same, also Denmark. So Denmark didn't come to this position. Let's make another example to understand the stable property. Below I will write an array 10, red 10, 5, 7, and 9. When we apply bubble sort on this list, at first we compare 10 with the red 10, and we do not swap 10 with the red 10, and red 10 keep its position same. After we compare red 10 with 5, after this comparison they will change their positions, but at first comparison these 10s didn't change their positions, so it is called stable. Now it's time to write our codes. We had 5 elements in our examples and we made 4 passes in total. So if we assume that for m elements we would make m minus passes. For m elements we need to make m minus 1 passes. So in order to represent our passes, we have to implement a for loop, and our for loop will start from 0 to m minus 1, because for m elements we made 5 minus 1 passes, and our first for loop I will be initialized to 0 and I less than m minus 1 I plus plus. And for each passes we are making comparisons and swap operations. So in order to make this happen, we need another for loop, and this will be the same as above. So our next for loop, j, will be initialized to 0, j less than m minus 1, j plus plus. So the first for loop will represent the passes, and the second for loop will represent the comparisons and the swap operations made in for each passes. First pass, second pass, third pass, and the fourth pass. These passes represented as our first loop, and the second loop will represent the swap and comparisons made in for each passes. The first pass we made 4 comparison, 4 swaps, but in the second pass we made 3 comparison and 3 swaps, and the third we made 2 comparison, and the fourth pass we made 1 comparison. So the number of comparisons reduced by 1 for each passes. So we need to reduce our loop with the amount of I, m minus 1 minus I. So in the first loop, in the first pass, I will be 0, and we will make 4 comparisons if we have 5 elements, and the second pass I will be 1, and because we are reducing by 1 in the second loop, we will make 3 comparisons if we have 5 elements, and in the second loop we have to make some comparisons. So if d will represent the name of the array, d of j is larger than d of j plus 1, and if it is larger we have to make swap operations, and we have to implement a swap function for this purpose. If d of j larger than the next element, we have to swap these elements. Swap with dj minus 1. I also explained the adaptive property of bubble sort. I mentioned that we have to implement a flag in order to make our bubble sort algorithm as adaptive. So we will use a variable to make our algorithm as adaptive. So before second loop, we will initialize our flag variable as 0. And inside the second loop, if we make any swap operations, it means that our list is in mixed order, so it is not sorted. If it is not sorted, we can say that flag can be 1. But if we don't make any swap operations in the first pass, so I will be 0, so it will be our first pass, and in the first pass this for loop will start, and in the first pass we will make some comparisons and swaps. If we have a sorted array, we won't make any swap operations, so our flag will be 0. So after this for loop ends, our flag will be 0. It won't be 1 because we didn't make any swap operations, because we assume that we have a sorted array. So in this point we have to check if flag is equals to 0, it means that we have a sorted array. So if this happens, we have to just write break in order to stop the for loop. Because in the first pass, if we do not make any swaps, it means that we have a sorted array. So if we have a sorted array, we do not have to make the other passes. So, and we stop our first for loop, so we do not continue our comparisons because we have a sorted array. Let's write our program in Xcode and see the results. So at first we have to add our IOStream library, and also I want to use namespace std, and now we can implement our bubble sort function. It will not return any value, so its return type will be void and its name will be bubble sort. Also, it will take an array as a parameter and its name will be d. Also, it will take the number of elements as a second parameter and its data type will be int. Its name will be m. So we have to create an integer variables for our loops I and j. And if you remember, our first for loop will represent our passes. It will start from 0 to m-1 I++, and our second loop will represent the comparisons and the swap operations that we made in each passes. J will start from 0, j less than m-1 minus I, because in each passes we reduce the comparisons and the number of swaps by 1, j++. And each passes we have to compare d of j with the next element d of j plus 1. If it is larger, we have to swap these values. Swap with j plus 1. So we have to implement the swap function. Also, our swap function will not return any value and its return time will be void and the name is swap. So make this capital S, swap integer a and integer b. Also, I need to create a temporary variable for the value of x, for the value of a, and a will take the value of b, and the b will take the value of a, which is stored in temp. So we swapped our two values. So in order to make our bubble sort algorithm, we have to add a flag variable and we will initialize the flag to 0 after the first pass, and each pass, if we make any swap operations, we will make flag as 1 to indicate that our array is not in sorted order. If it is in sorted order, we won't execute this line and we will skip this for loop, and after this for loop we will check the flag variable. If it is equals to 0, we will just break the for loop. Now we have to implement our main function. I will declare an array with 10 elements and the array elements will be 5, 9, 12. And the number of elements will be stored in our integer variable m equals to 10, and we will call our bubble sort algorithm. The first parameter will be d, and the next parameter will be m, which is 10. And after we sort our array, we can write a for loop to show our sorted array elements. Okay, let's run our program and see the results. Yes, our array is sorted. Now 5, 7, 9, 12, 20, 23, 30, 35, 43 and 62. Our new array is in sorted order now. Yes, this is the end of our bubble sort algorithm video. I hope you liked the video. See you next time.